Alright, so now we're going to be solving radical equations. So the first part says equations with radicals that have variables in the radicands are called radical equations. Alright, so to solve a radical equation, you're going to follow these steps. The first thing you're going to do for step one is you're going to isolate the radical on one side of the equation if necessary. Step two, you're going to raise each side of the equation to the same exponent to eliminate the radical and obtain a linear, quadratic, or other polynomial equation. And step three is to solve the resulting equation using techniques you learned in previous chapters, and then you're going to check your solution. Alright, so let's look at the first one. It says, solve the equation, check your solution. Alright, so we're still going to go with PEMDAS backwards. We're going to look for addition or subtraction from left to right first. Then we're going to look for, SAD MEP, division and multiplication, whichever one comes first from left to right. Then we're going to try to get rid of the exponent, and if there's parentheses, we'll go back to that. Okay, so for letter A, I have 2 radical x plus 1 equals 4. So I'm looking for addition or subtraction outside of this radical sign. I don't have that. Next thing I'm looking for is division or multiplication, and I see I have this 2 right here, which is being multiplied. So to undo that, we divide both sides of the equal sign by 2. So 2 divided by 2 reduces to 1, so I don't need that. So I'm left with the square root of x plus 1 equals 4 divided by 2, which is 2. Now here, we're already at the second step where it says to raise each side of the equation to the same exponent to eliminate the radical. Since we usually typically call this the square root, we're going to square both sides to get rid of that. So I'm going to put this in parentheses and square it. Put this side in parentheses and square that as well. So what happens is a square root and a square root inverses, so they cancel each other out, leaving me with what's inside the radical, which is x plus 1. On the right side, I have 2 squared, so 2 times 2 is 4. And last, to solve for x, to isolate it, we subtract 1. So 4 minus 1 is going to be 3 is my solution. Alright, I'm going to check to make sure this answer is correct. So what I'm going to do is I'm just going to type this 3 in here. So 2 square root of, instead of x, I put the 3 plus 1. And it should simplify to 4, and it does, so that answer does check out. Alright, for the next one, starting from the addition subtraction. Here I do see a minus 1, so to undo that, I'm going to add 1 to both sides of the equal sign. So we have the cube root of 2x minus 9 is equal to 2 plus 1, which is 3. Now, to get rid of a cube root, so to get rid of a square root, we squared it. To get rid of a cube root, we are going to cube it, so raise it to the 3rd power. Okay, so the cube root and the cube were inverses, so they cross out, leaving me with what's inside the radicand, 2x minus 9. And 3 to the 3rd power, so that's 3 times 3 times 3, which is 27. Next, we're going to, we don't have an exponent, we already got rid of that, so now we go back to here, addition, subtraction, so I'm going to add the 9 to both sides to isolate the 2x. This leaves me with 2x equals 27 plus 9, which is 36. Divide both sides by 2, and we get x equals 18. And once again, we just plug this into our calculators. Let me put it over here this time. Let's see. So we have the cube root of 2 times x, which is 18, minus 9, arrow out, minus 1, and it should come out to equal 2, and you can see it does, so this answer does check out.